Okay, in this video we will be discussing the product and quotient rule. With our product rule, remember we will use this anytime we have the product of two functions. And so here, whenever we walk through our steps, it's good to identify the first and second. And so here we're going to have f prime of x equals our first function times the derivative of the second. So the derivative of x is 1, derivative of 4 is 0, plus the second times the derivative of the first, so that's going to be 2 minus 0. And we would want to clean this up just a small bit. So that's going to be 2x minus 1 plus 2 times x minus 4. And you can stop there, or you can distribute, whichever. Just if you do simplify, please make sure it is correct. Okay, for our next one, we have y prime equals, we have the first times the derivative of the second, so we're going to have 4x minus 0 plus the second times the derivative of the first, so 2x plus 3, and again the derivative of minus 1 is 0, and you're welcome again to leave it just like this. Okay, for our next part, 2 cosine x sine x. So what we need to do with this one is realize this 2 is really 2 times all this, and so that can just be brought down, and we need to focus on the inside of those brackets. Oh, not y squared, goodness. Y prime equals 2 times, and again it's going to be the first times the derivative of the second, so negative sine x, plus the second cosine x times derivative of the first, which is cosine x. Now, if you want to simplify this and put it together, sine x times negative sine x, that's negative sine squared x plus cosine squared x. All right, moving on to the next one. Again, we're doing our product rule. G prime at x equals, we're going to have our first times the derivative of the second plus the second times derivative of the first. So that's going to be 3e to the x. Derivative of 3e to the x is 3e to the x minus 2x. And again, you're welcome to leave it just like this. Whenever I look at this quotient rule, I always refer to the numerator as the top and denominator as the bottom. But there's several different ways, and whichever way you want to refer to it, the important thing is order does matter here, so be very careful. All right. And now let's go through and practice our quotient rule. Very important that we know how to do this. So we have g prime at x equals, and so again you start with the bottom times the derivative of the top minus the top times derivative of the bottom, and it is all over the bottom squared. And so you're going to leave it just like that. Okay, looking at our next problem, again, top and bottom here. So g prime at x equals, we're going to have the bottom times the derivative of the top. The derivative of e to the x is e to the x minus top times derivative of the bottom, and that's all over bottom squared. All right, moving on. Okay, and again, more practice. The more you do, the better you're going to be. So here, f prime at x, you're going to have the bottom times the derivative of the top. The derivative of natural log of x is 1 over x, and then minus top times derivative of the bottom, which is 1, all over the bottom squared. Okay, looking at our last one here, we're looking for y prime. And again, you have the bottom times derivative of the top, so that's cosine x, minus top times derivative of the bottom, so that's negative sine x, and that is all over 1 plus cosine x, all squared. You can simplify this up a little bit or leave it like it is. Either way, we should be fine. Okay, for our next problem, we're looking for the equation of the tangent line. Now, every time you see the words equation of the tangent line, you need to be thinking about your point slope formula. And so that point slope, for you to remember, you need to have y minus y sub 1 equals m times x minus x sub 1. Now, from that, you need to know what x sub 1 is, what is y sub 1, and you need to know what is the slope at x sub 1. So it's always a good idea to make yourself a little list over to the side so you can keep track of what the information is that you need. So here is a list of what we'll be looking for. Now your x1 and y1 should be some initial value that you're given. So that for this problem is 0 and 1. And so that means I need to find f prime at 0. That's your slope. So let's go plug in here after we do our derivative. So again, we need our quotient rule here. So we have f prime equals, again, it's going to be the bottom times the derivative of the top. Oh, that's negative sine, goodness. Negative sine x minus top, so that's cosine x, times the derivative of the bottom, so negative cosine x, and that's all over the bottom squared. Now we need to substitute in to find f prime at 0. So when we do that, let's see, if we plug in and we can mental math this, that's going to be 1 minus sine of 0 is 0 times 0. And then we've got minus a negative here, so plus cosine of 0 is 1 times 1 all over 1 minus 0 squared. So it looks like my slope is going to end up being 1. So now I have everything I need to substitute in and find our equation. So we're going to have y minus 1 equals 1 times x minus 0. And so simplifying this, we have y minus 1 equals x. So y equals x plus 1. And that looks like that's going to be the equation for part C. Okay, for these, we are going to go through and we are going to develop the rule that's needed in order to find all of our trig values. So the first thing it might be a good idea to do is to rewrite this to be 1 over sine theta. And now let's find our derivative. F prime at theta, again, is going to be the bottom times the derivative of the top minus the top times derivative of the bottom all over the bottom squared. Okay, and so let's see what that's going to give us. We're going to have f prime at 0 or at theta equals, of course that's going to be 0, so I have negative cosine theta over sine squared, and let's break that apart to be sine theta times sine theta. Okay, and so now we can change this around. Keep in mind cosine over sine, and I'm going to bring over my negative as well. Cosine over sine is cotangent theta, and then that leaves me with 1 over sine. Well, 1 over sine is cosecant. So you can develop this each time, or we can memorize, and most kids choose to memorize, that if I do the derivative, it's not equal, but the derivative of this is going to be negative cosecant theta, cotangent theta. All right, so now we're going to go through the same thing with secant. And again, I'm going to rewrite this to be f at theta is 1 over cosine theta. And we're going to do our quotient rule again. F prime at theta, we're going to have the bottom times the derivative of the top minus the top times derivative of the bottom. And that's going to be all over the bottom squared. All right, again, this is going to go out to 0. And so f prime of theta is going to be equal to, that's going to be plus a positive. So I'm going to have sine theta over, and then notice we're going to have cosine theta times cosine theta. And so just like earlier, we can put together some of these, like sine over cosine. That's going to give me tangent theta. And then 1 over cosine, because there is a 1 left up there, that's going to be secant theta. So the derivative, f prime of theta, is going to be tangent theta secant theta. And the order in which you write these is not going to matter because you are multiplying them. All right, so now let's go to part C and develop it. So let's see, f of theta, if I rewrite this, is going to be sine theta over cosine theta. And so f prime of theta, that's going to be the bottom times the derivative of the top minus top times derivative of the bottom, which is negative sign. So I'm going to put a plus there so we don't have so many signs floating around. And that's going to be all over the bottom squared. So that's going to be cosine theta squared. All right, so let's see. F prime of theta is going to be cosine squared theta plus sine squared theta all over cosine squared theta. Now this is going to be a trigonometric identity. Cosine theta plus sine theta, that is all, or cosine squared plus sine squared is always equal to 1. So that's going to be 1 over cosine squared theta, and 1 over cosine is secant. So that's going to be secant squared theta. So the derivative of tangent is going to be secant squared. All right. And again, you can learn how to develop these or memorize them, and most kids just choose to memorize them. Okay, now let's try cotangent. Again, we can go through and develop this. Couple of ways to do this one. I would just rewrite it as cosine over sine. Okay, so f prime of theta, we're going to have the bottom times the derivative of the top minus top times derivative of the bottom. And that's going to be all over bottom squared. All right, so let's see what we can simplify here. So let's see, f prime at theta is going to be negative sine squared theta minus cosine squared theta all over sine squared theta. Well, this is almost that identity that we were talking about. Notice you have a GCF in the numerator. That's a negative. So let's factor out the negative. So we're going to have sine squared theta plus cosine squared theta. And that's going to be all over sine squared theta. And the reason why we do that is so that this entire identity now will be canceled out. It has a value of 1. So now we have negative 1 over sine squared, and that's going to give me negative, let's see, 1 over sine squared is going to be cosecant squared theta. So over here, the derivative of cotangent is going to be, here, f prime at theta is going to be negative cosecant squared theta. All right, now that we've gone through those, let's go ahead and make us a chart and fill in what we know about these derivatives. So here the derivative of sine of theta is cosine of theta. The derivative of cosine is negative sine theta. Derivative of tangent, we saw that to be secant squared theta. The derivative of cosecant is going to be negative cosecant theta cotangent theta. Derivative of secant is going to be secant theta tangent theta. And finally, and the derivative of cotangent was negative cosecant squared theta. So please, please, please learn these along with your trigonometric values. All right, so this is a way to help you avoid jumping straight to the quotient rule every single time, because sometimes other ways to approach it would be a little bit quicker. Like for instance, this one, we could flip this over and rewrite it to be x minus 4. Of course, to the 1/2 because you are taking the square root, and negative because you needed the reciprocal. And that's going to help us because whenever we come over here to do all of that differentiation, we're going to say y prime equals negative 1/2 times x minus 4. We're just doing our power rule, subtracting 1, so that's negative 3/2. Of course, we need to multiply by the derivative of the inside, but it's still just a 1 there. So we have y prime equals, we're going to have negative 1 over 2's in the denominator, and this negative exponent means to move to the denominator. And so there would be your answer. So it's just another way to go through this process and think through which way would be the shortest. So for instance, here on y, you're going to divide this one up since you have just a term in the denominator. You're going to have 6x to the 5/2 over x minus e to the x over x. And here we can simplify this down and say, well, really, here, if you're dividing with like bases, you need to subtract your exponents, and it's always top minus bottom. So 5 over 2 minus 2 over 2 is 3 over 2. So this is 6x raised to the 3/2 minus, and then this would need to flip up to the top. So that's e to the x times x to the negative 1. Now you can do your derivative. So here, y prime is going to be equal to, and remember you're bringing down your 3/2 times 6x, and we're going to subtract that, or subtract 1 from here, so that's going to be to the 1/2. And then we're going to have here the product rule, so I'm going to have minus, and then I'm going to do a bracket because I've got to multiply those together. So I'm going to have my first times the derivative of the second, so that's going to be negative x to the negative 2, plus the second times derivative of the first. All right. And so let's see what we can do as far as simplifying. Not too much though. We can cancel here. That's going to give me 9x to the 1/2 power minus, and then on the inside here, that's e to the x over x squared. You don't want to leave a negative exponent if you can help it. and we have a negative there, so I'm going to put that in the numerator, plus, and then this is going to be e to the x over x. And you can leave it just like that. All right, and we're going to do that same method over here. And again, a couple of ways to do it, but again, it's a good idea to try to divide this up. So for this part here, we're going to rewrite that. We're going to have y equals, that's going to be 6x to the 4th, but that's over x to the 1/2, plus x cubed over x to the 1/2, minus 2x over x to the 1/2. And again, you do need to go through and subtract your exponents. So here we're going to have 6x, and then 4 minus 1/2. Well, that's 3 1/2, which is 7/2. Plus, and 3 minus 1/2. That's going to be 6 over 2 minus 1 over 2, so 5 over 2. And then here minus 2x to the 1/2. Now we're ready to do our derivative. So we're going to have y prime equals, you are multiplying down your 7/2 times 6x, and if we subtract 1, that's going to give us 5/2, plus 5/2 times x to the 3/2 minus 1/2 times 2x to the negative 1/2. All right, now let's simplify up just a little. We're going to cancel here. That's going to give me 3. So I'm going to have 21 x to the 5/2 plus 5/2 x to the 3/2. And then here we've got minus, and the 1/2 and the 2 can cancel, and I'm left with 1 over x to the 1/2. And you're welcome to leave it just like that. Okay, now that we know something about derivatives, we can start talking about particle motion. And this portion right here is very important for us to know. This is what we like to refer to as PVA. And just like our sine cosine little chain, PVA can also be thought about in that chain of events. And as you're moving down, that is your derivative. And if you're moving up, that is your antiderivative. And so that's good for us to remember for sure. All right, so for all of these, they want us to find the second derivative. So let's go through and check to see, do I need to rewrite any of it? And I don't. So now let's pick up and try to do the second derivative. So before we get to the second derivative, we'll have to do the first derivative. So I'm going to multiply that 3 down. So that's going to be 9/2 x squared plus 10x minus 6. And now let's go to our second derivative. And so that's going to give us 9x plus 10. All right, so now let's look at part B. And notice part B just has a single x in the denominator. So I would rewrite this. I would make this x squared over x minus 4x over x minus 5 over x. And so here, g of x, and I would go ahead and simplify. So that's going to be x minus 4 minus 5x to the negative 1. Now let's do our derivatives. So x prime, that's going to be 1 minus 0. And then here that's going to be plus 5x to the negative 2. And so to rewrite this, because you don't want to leave that negative exponent, that's going to be 1 plus 5 over x squared. However, I would leave it like this because, again, you've got to go find that second derivative. So it's good to finish this out for an answer over here, but you're going to refer back to this when you're doing your second derivative. So here, the derivative of 1, that's going to give me 0. This term was already gone. And then this one, you're going to get minus 10x to the negative 3. And we can simplify that to be negative 10 over x cubed. So you sure didn't want to do the second derivative with the quotient rule here. So it's another place where rewriting it really does help. All right, so for this one, there's not really a whole lot of rewriting we can do, so we're just going to have to struggle through this one. So y prime, we're going to have the bottom times the derivative of the top minus the top times derivative of the bottom all over the bottom squared. Okay, now again, just like earlier, I would try to simplify this since I'm doing a second derivative. So here we would have x plus 2 minus x. That's just going to be 2 over x plus 2 all squared. Now, I would rewrite this. This can be moved up to the top. So y prime, notice again I'm still talking about the derivative, can be rewritten to be 2 times x plus 2 raised to the negative 2. Now we can do our second derivative. That's going to be negative 4 x plus 2 raised to the negative 3. And then we can go ahead and move that negative exponent down. So negative 4 over x plus 2 all cubed. All right, so now let's look at part D. And part D, again, some great rewriting here. So we're going to have f of x equals 4x to the 1/2 minus 6x to the negative 1/2. So f prime at x is going to be 2x to the negative 1/2 plus 3x to the negative 3/2. All right, so here we can go ahead then and see if we can't get through our next derivative, and then we can come back and clean up if we need to. So f double prime at x, that's going to be negative x raised to the negative 3/2 minus 9/2 x to the negative 5/2. And now we definitely need to do some rearranging. So f double prime at x is going to be negative 1 over, and that negative's coming from right there, x to the positive 3/2. And then we have minus 9 over 2x to the 5/2. Okay, now we're going to use some of our trig stuff in this. So again, going through, finding our second derivative, we've got to find the first one first. The derivative of sine is cosine theta. And again, minus 3 is just your coefficient. And then the derivative of secant is going to be secant theta tangent theta. Right, now we need to go through and find our second derivative. So the derivative of cosine is negative sine x, or sine theta, minus 3 again is just coming along. And now let's go through and see if we can't do our derivative. And we need the product rule right here. There's that secant times tangent. So we're going to have the first times the derivative of the second, so that's secant squared theta, plus the second, oops, I need tangent there, don't I? Times the derivative of the first, which is going to be secant theta tangent theta. All right. And so let's see what we can put together here. We've got h double prime at theta. It's going to be negative sine theta minus 3 times, and then in here we're going to have secant cubed theta plus secant tangent squared. So we have secant theta and then times tangent squared theta. And that would be about as simple as you would need to get it. That should work. All right, looking at our next problem. Again, this would be a position function, most likely. And so s prime at t, which would give me the velocity of the particle, that's going to be negative 32t minus 3 sine t. There's your derivative. And then your second derivative is actually going to give you your acceleration. So that's going to be negative 32 minus 3 cosine t. Here's another way that you could see derivatives asked. And this is going to be with a chart. Notice that notation. This is f times g, and then they want the derivative of that at 2. So you do need your product rule because, again, that's f times g. And keep in mind that that product rule, and we're going to sub in a 2 as we're doing this. So we're going to have our first function at 2 times the derivative of the second at 2 plus the second at 2 times the derivative of the first at 2. And now let's go read our chart. So f at 2 is 8 times g prime at 2, which is negative 1, plus g at 2, 4, times f prime at 2, which is negative 2. So we're going to have negative 8 plus negative 8, and so my derivative is negative 16. All right, so part B, we're going to have our quotient rule. And again, it's going to be the bottom, and we're going to go ahead and plug in all at the same time. So it's the bottom, g at 2, times the derivative of the top at 2, minus the top at 2, times the derivative of the bottom at 2. And that's going to be all over the bottom at 2 squared. And so now we're going to go evaluate. So we need to find our values. G at 2, that is going to be 4 times f prime at 2, which is negative 2, minus f at 2 is 8 times g prime at 2, negative 1, and that's all over g at 2, all squared. So that's going to be at 4 all squared. And so this is going to give me negative 8 plus 8 all over 16, and that's going to give us 0. Well, my pen died. All right, over 16 and 0. All right, so now let's go look at part C. And part C says find f prime at 2 if f equals the product of x squared and f at x. So notice that is the product. So let's do our product rule. And we're going to evaluate this at 2. So we're going to say f prime at 2 equals. In our product rule, we have our first times the derivative of the second plus the second times derivative of the first. All right, and now let's go through and evaluate. So f prime at 2, that's going to be 4 times, and f prime at 2 is negative 2, plus f at 2 times 4. So it looks like we're going to have negative 8 plus 32, which is 24. All right, so now same idea here. Keep in mind that g prime or g at x squared, you can rewrite that as a product of g of x and itself. And now we can go through and say, well, g prime at 2 is equal to, and again, it's the first times the derivative of the second at 2 plus the second at 2 times the derivative of the first at 2. And so if we really have the same value here doubled, it's almost like it's twice that amount. So let's see, g at 2 is 4 times g prime at 2 is -1 plus -1 times 4. So it looks like you're going to get -8 here. Okay, for our last problem, we're going to write the equation of the line tangent to the graph of this when theta is pi over 3. So again, when we see something like that, keep in mind we need y minus y1 equals your slope times x minus x1. So what you need to do is go ahead and figure out, well, what values do I have? Now, in this case, theta, you can think of theta as your x1. That's quite okay. So let's make a list of things we need. We need x sub 1, and that's given to us. It's pi over 3. We need y sub 1. That was not given to us, but we can plug into our function and find it. And then I need my slope, which is f prime's value at pi over 3. All right, so to find y1, then we need to go plug in. So over here to the side, and change the color so we can see. So f at pi over 3 is going to be equal to sine of pi over 3 times tangent of pi over 3. So sine of pi over 3, that's at 60 degrees, so that's root 3 over 2, times, and again, here we're just going through and evaluating, trying to find that, and let's see, that's going to be times tangent is going to be just root 3. And so that's going to give us 3 over 2. So our y value is 3 over 2. Now we're ready to go do our derivative. And notice that you will have the product rule because we have the product of two functions. So to do that, we're going to have f prime, and we still need to evaluate that at pi over 3, is going to be our first, so sine of pi over 3, times the derivative of tangent, well, that was secant squared at pi over 3, plus our second, which is going to be tangent at pi over 3, times the derivative of the first, so that's going to be cosine at pi over 3. So there's our problem written out. And now let's go plug in our values. So we have f prime at pi over 3. Sine at pi over 3 is root 3 over 2. And times, and secant at pi over 3 is going to be 2. So that's really 2 squared. Plus tangent at pi over 3 is root 3. Times cosine at pi over 3 is 1/2. And so this is a terrible looking mess. F prime at pi over 3, or the slope of this, is going to be, there's 4, 2 cancel, so that's going to be 2 root 3 plus root 3 over 2. And I'm tempted to leave it like that, but we can simplify this, put that over 1, crisscross it, so that's going to be 4 root 3 plus 1 root 3 over the product. So we're going to get 5 root 3 over 2. All right, so now we need to go back and actually write the equation of this line. So we found our slope, though, to be 5 root 3 over 2. All right, so let's go plug in. So I'm going to have y minus 3/2 equals our slope, so 5 root 3 over 2 times x minus pi over 3. And let's go ahead now and get in the habit of going ahead and adding that 3 halves over, so that I have y equals 5 root 3 over 2 times x minus pi over 3, and then plus 3 halves.